Okay, let's start with the big crowd. Blue sheet is. Yeah. Welcome to the IETF DTN working group. Thank you. All discussions, everything that we write, say, or anything on is under the note. Well, proposed agenda, hopefully, the last presentation about TCPCL, so that we can forward it to the right people upstairs. BPSec updates, bundle in bundle, and custody transfers, who were kind of a move out of the BPBIS base document, and then management. Any agenda bashing or changes suggested? Okay. Ed, would you take notes as usual? Thank you very much. Jabber room, yeah. Anyone who wants to relay on the Jabber? I don't know if you have. I haven't been watching. Milestones. We've done working group last calls on those two documents. We wanted to send both to the ISG at the same time, given that BPBIS by itself requires, a convergence layer of some sort. We've been discussing TCPCL since then, and hopefully it will be final and sent to the ISG very soon. This is the milestones for the working group and the charter, current charter. I kind of removed from the previous presentations all the small stuff, but essentially we do have security protocol, addressing architecture, naming, node discovery. So a lot of stuff to do. With that, unless there's other comments, let's move to, yes, Scott?
Scott Burley. Was there were going to be three documents taken together at the same time, right? TCPCL and BPBIS and also security. Did we not go through last call on BPSec?
I've been kind of saying, let's push the TCPCL and BPBIS first to the ISG.
Oh, okay, cool.
Because if there's any changes, kind of a substantial changes, then they may impact BPSec, right?
Sure.
So,
my impression had been that the area director wanted all three of those to go forward at the same time. But if we're good with BPBIS and TCPCL, then I'm fine with that. I just want to bring it up.
Well, we could do like one after the other, right after the other, right? But we're not really successful in sending stuff to the ISG fast, but so Brian, I don't know if you're here. Cool. We are not hearing you. Not sure why.
Oh, okay.
Now it's better.
Great. Okay. So there's very few slides here. It's just really a delta from the earlier version. So this is only discussing roughly in what is in the CL itself and focusing more on what are the last changes since the last IETF and the feedback after that IETF. So next slide, please.
Sorry, Brian, is there any chance you could turn your microphone up a little bit? You're very quiet at this end.
Let me try.
Oh,
Giving it a try.
no, it's still very quiet.
It's on the headphone cord. Just bring it up.
Yeah, could you try bring the mic on your headphone cord up closer to your mouth? Sorry, it's
Yes, okay.
Yeah, that's better. That's
Okay.
much better.
All right.
Go ahead, Brian.
So this is just a summary of really the changes since the last IETF and the feedback received since then, with a little bit of boilerplate still left in the presentation. So if you could go to the next slide. This is really what I just talked about. And also, there's a little bit of discussion about the prototype that was made at the end of the current state of the draft. Next slide, please. So all the motivations for the convergence layer update are still the same as they were. I did add another item here just for people's reference that 1 through 4 have been the same throughout, but the last set of changes to the spec were to add extension capability for both the connection, the session itself, and the individual transfers. Although right now there aren't any actual extension uses defined, but the capability and the mechanism is there. And it still roughly follows the nomenclature and the workflow of TCP/CL v3. And even these last changes were made to simplify and to avoid variations in the protocol workflow. Next slide, please. The overall what the CL is doing is still the same since v3, although there have been a lot of fiddling with the mechanisms of how to do this. The second sub-bullet item about the still using contact negotiation and existing headers and type codes, that applies less now than it did, because we have set aside separate IANA registries for the v4 type codes from the v3, but somebody who's familiar with v3 should be able to pick up v4 and understand what's happening relatively quickly. The one thing that has changed in the last draft that I'll talk about in a second is there still is a single phase contact negotiation, but it actually is split between a pre-security and a post-security negotiation. So if you go to the next slide, we can discuss this. So the 09 revision of the draft did make it in before the IETF, although it had been a bit late in coming. The major changes to the document itself are to try to simplify understanding in the earlier sections of what the draft is defining and what the protocol is doing. So it adds some state definitions. It adds names to the roles of the entities involved in the protocol. It defines an active and a passive side of a session. It defines some terminology about the states of an individual session, the states of a transfer, and some diagrams to make it hopefully easier to understand how the both ends of the roughly symmetric session operate. The workflow really is the same rough workflow from v3, but these are more intended for somebody who's not familiar with how the CL operates. The third item here is a change to the protocol encoding definition, actually. There was a lot of feedback about the security implications of how it was structured before. It was really a holdover from v3. In v3, there was no concept of a secured session, so there was no distinction between pre-security and post-security exchange of data. This last edit does split the two. It's still unidirectional in the sense that once you progress past the negotiation stage, you can't renegotiate. It still only goes one direction. But at this point in the 09 version of the draft, the only unsecured data that's transferred is the CAN TLS flag and all of the magic octets that establish that you are talking to a TCP/CL node. So what this does is it guarantees that an implementation simply can't provide any unsecured data if they don't want to provide any unsecured data. It's not possible to leak the negotiated contact information. And the fourth item here is a simplification in terms of workflow from the, in terms of sequencing from the last reversion of the draft and V3, which is that the connecting entity always sends the contact information first, and the receiving, the listener, always waits for a contact message. So that makes the sequencing of things a bit easier, a bit simpler. And it avoids the possibility of some kinds of, not leaks of information, but leaks of resources if there was a bad actor on a TCP/CL network. The transfer extension capability was added, which is really just an identical encoding to what had been specified for the session extensions. There's a different registry, so there's a whole set of types of session extension items from transfer extension items. Right now, there are no actual item types defined by the spec, but the capabilities there. And there was some cleanup done about failed TLS handshakes and failed connection attempts, just again to avoid avoid sending any data on the wire that really doesn't provide any information and is something that could be a vector for unnecessarily wasting resources if there's a misconfigured or a bad actor trying to connect. Next slide, please. So all that being said, had been said about the prior revision, that
Lost you. We lost you for a second there, Brian.
I'm back. Okay.
Start again.
So this had been said before, but it is being said again that the current draft of the spec is all there in the sense of defining everything that needs to be defined to implement the protocol. And there is now in the draft spec with an editor's note to take it out, a reference to the prototyping implementation to be used, that could be used for interoperability testing or just establishing that yes, the protocol is implementable. It follows a single path through the workflow for a lot of these things, so it does do a minimal amount of error handling, but it doesn't really allow you to exercise weird situations of messaging. It's just really supposed to be proof of concept for the normal path of session establishment and transfers. And it doesn't have anything to do with BP itself. It's purely chunks of data going from one end of the session to the other end of the session over TCP. So that's where things stand right now. And all of this was changed to address the last comments that were received against the earlier draft of the CL.
That's it. Okay, thank you, Brian. This is good stuff. I need to reiterate to the working group again that this work is vital. really, we have to get this done. We have to get this pushed to the ISG as fast as possible. It's been resting in working group last call, and Brian has done lots of good work on this, but he is working pretty much solo at the moment. So we need more feedback for comments as fast as possible. So please have a look at the latest draft. I know, chair hat off, I've looked at it. I think it's in a very good place now, but we need to make sure that the working group is happy and the clock is ticking on this, because Mark, you said 2-week window and we push the button. I'm trying to remember. Yeah, of course. Go with the questions first.
Hi, Stu Card. Just one question. I didn't find anything in the draft, and I hope there is nothing in the draft that would prohibit my using various TCP options. The reason I ask is in the same kinds of environments where the bundle protocol would be very handy, having an extremely robust TCP would be very handy. And I've made extensive use in the past of skips TP, opt 20 hex. I just want to make sure there's nothing in there that would say I can't do that.
Sure. I should have, looking back, I should have included the new diagrams in the presentation, but I didn't. But the very first state on the TCP-CL diagram is you already have a TCP connection. So that's really the starting point of the CL, and it really leaves up to the network, the implementation, where and how that TCP connection comes about. So I believe that there shouldn't be anything in there preventing the underlying TCP socket interaction from being whatever it needs to be.
Rick here, as a follow-on to that, if you feel there needs to be clarifying text, can you just review the document, just check it does cover this? I agree with Brian. I think you're fine. If you feel it needs text, can you suggest some or give us a +1 on the list for this? So to reiterate, the desire of the chairs, if everyone is happy, is to make this a 2-week last call and then press the button. One thing I will say is Brian has done sterling work on this. I know there were lots of original authors from TCP/CL v3 and guys involved with the early days of the v4 documentation. I'm sort of trying to reach out to them to say, can you assist Brian? And Brian, can you collaborate a little bit? This is meant to be a constructive request, not a criticism, because as soon as we get into the IESG pipeline, there will be AD reviews that will need addressing promptly. There will be editorial nits that need to be addressed. And it's important for the working group that we've all got day jobs, just to make sure that we're not all just standing looking at Brian waiting for him to do. So if people want to assist, I'm looking at Jorg, for example, please step up, and Brian, please use them.
Okay.
But otherwise, and the onus on the rest of us is please review this and check this is good, because otherwise it's happening. Silence is assent.
One last area that would be useful to get some feedback on is there was some comments earlier about discussion within the spec, within the draft of the should and optional behaviors. And I really have not gone through and scrubbed all of the cases of should and may to see if there's guidance on when it's not appropriate. So if anybody who does browse through it has particular shoulds or mays in there that it's not clear when the should or may applies and what the implications are to them, that would be a useful piece of feedback to have.
I mean, a lot of those will be picked up by the ISG, but it would be better if it left here correct. It's just a bit embarrassing when the ADs turn around and say, you've got this sort of stuff wrong. But from Brian's perspective, and I agree with him having written these drafts, it's hard to get this bit right. So I think that's an action for the rest of us in this room and online to go have a look at it, just double check the required mandatory wording. Okay, thanks, Brian. I think we'll move on to the next
All right.
item. So Ed, BPSec.
So, hello, my name is Amber Rain. I want to talk about two things today: the BPSec security protocol, which just had security AD review comments coming back, and the interoperability cipher suite draft, which goes with the BPSec protocol. So, just going through it, we did, through several previous working groups, we had decided that sending the protocol to the security area for an early review would be good to make sure that we had not missed anything significant before we put the document into come out last call and to yeah.
A bit close to the mic.
All right, is that better?
Is that mic on?
No, it wasn't. Is that better?
Yes.
Even I can hear me now. So to repeat briefly, again, we made a decision as the working group to submit the standard, proposed standard to the security area for an early review. We did get comments back from that early review. Additionally, we had sent the spec out to other standard body security review areas, and we got some minor comments back from them as well. So I want to explain what those comments were. I want to walk section by section the changes that were made to the standard between BPSec 06 and 07. There were a couple of small questions that I wanted to bring up to the working group, and then to move over into the interoperability cipher suites, and then finally just talk about a discussion on how we choose to represent extension block type specific fields in BP, which may be overcome by events from the mailing list. So, starting with the IETF security area review, the review early disposition was almost ready. So as I understand it, there are three rough dispositions: ready, almost ready, and not ready. Almost ready means that it's almost ready. The three comments that came back, I think that's what it means. So tautologies aside, there were three comments that came back. One was, there was some confusion on the point of view of the reviewer as to what we meant when we said integrity as it relates to encryption. This did not necessarily turn into a change in the format of the specification or how the protocol handles things, but we did have to clarify some text. Additionally, we clarified, and at the reviewer's request, put in a stronger statement that when you are using encryption in BPSec, you must use an AEAD cipher suite, which really means a cipher suite that generates an authenticated encryption and perhaps other additional data associated with it. To Rick's point from before, there are RFC 2119 wording questions. Sometimes we used all capital maze, sometimes we used lowercase maze, and I tried to clean that up as best as I could. And then the last was just a comment on the security considerations. So I want to walk through these briefly one by one, but the full comments are available at the link below. So the first comment that came up was essentially, and emphasis is mine, it mandates authenticated encryption. The security AD feels strongly that if you were to not have authenticated encryption, how do you understand if your decryption has failed? How do you understand if something else has been substituted along the way? It was certainly something that we had always envisioned would be part of any operational cipher suite, but in our opinion, it makes it's not harmful because of that to say that any BCP cipher suite We could say we understand some format of the plain text, meaning it is a byte string and it has some sort of a length designation followed by the data. We could take the length away, feed the data as the plain text, understand that if our ciphertext is the same size as the plain text, the length won't change, and now our encrypted data is of the same size, and we now have the length, and the overall thing has not grown in size. But we can't do that if we have an array. If we have an array, then we need to take that entire thing as plain text. We will generate ciphertext, but then we have to put some length on top of it, which can be 1, 2, 3, or 4 bytes, depending on how long that plain text to ciphertext is. So what do we do in that case, right? So if we choose to represent extension blocks with things like arrays or really anything other than byte strings, every time we encrypt, we're going to result in ciphertext that is larger because it has to be encoded. So the question is, can BPBIS always represent block type specific fields as byte strings, because it certainly makes things easier for us and it probably doesn't hamper other things. But then the other is, even if we were to do that, is it seen as a violation to somehow meaningfully parse the context of plain text to say, well, we are assuming that the beginning of the plain text is a CBOR length and are going to sort of use it or abuse it as such. My recommendation, of course, is that we should represent things as byte strings and that it is not an abuse to do this, but it's an open question to the working group.
Scott Burley, and I'm for option A there. I think it is the simplest thing. Just the block type specific fields, just always make them byte strings, always precede them with a length. I mean, they're preceded automatically with a length by being CBOR byte strings. The simplicity of that is very appealing, and I can see cases where it also would be more bit efficient. So I think it's the best way to go.
Rick, without a chair hat on, how does this, I'm just trying to quickly checking my mailing list mailbox. How does this interact with the block length field discussion that was going on? It seems to be this is another manifestation of the same issue.
It is, yeah.
Right.
What the original discussion had been was, well, the original discussion had been that the block type specific stuff is going to be CBOR encoded anyway. Why have a length field in front of it? Because all the elements of block type specific stuff are self-delimiting, which is true, right? And so you arguably you can save a little bit of data by leaving that length off. And then that was revisited on the mailing list in the context of this simplicity question. And I think the sense on the mailing list has been that this is the best way to go.
So that is all I have.
Are you aware of any, Mark here, are you aware of any implementation?
So there is I'm not aware of a full implementation of this spec. There was a partial implementation that had gone into ION, which dealt solely with applying these blocks to the payload block without the security target. But I think we need a BPBIS v7 implementation to have the blocks represented as is first, which I think we may have now. And then the next thing would be a BPSec implementation.
Right, there are two, at least partial BPBIS implementations. So you could conceivably do a BPSec implementation integrated with those. Probably the more complete one is the one from the guys in Dresden. The one that is in ION is really sort of the interim streamlined bundle security protocol specification, which can't be the entire BPSec because it's based on RFC 5050, which lacks block identifiers, which is required for the new iteration of BIBs and BCBs.
Mark, again, I'm asking the question because I wonder if we got reviewers and reviews of this spec, because it's a pretty complex spec, from the point of view of an implementer, which, may not have happened, which, I'm not sure how much we have exercised the actual spec really as a implementer point of view. IETF standards do not require implementations for the first level of the standards, the proposed standards. But at the same time, it's kind of reassuring because, you have a different eye when you want to implement something. And especially for a complex spec like this, which actually depend on another not so simple spec too. So.
Well, so agreed. I will say though that a lot of the impetus for what was SBSP that then in IETF became BPSEC was the lessons learned we have of trying to implement BSP, and so we certainly had things from there. And most of the work that we've done here is to actually remove features and functionalities from BPSEC. But I would say that the seaborne coding of this data is new. And is something that probably could be prototyped fairly quickly and maybe by the next meeting.
Right. It's clear that we're not starting from zero, but at the same time, when you read a spec from, I did implementations and, you go into all the details and, there's a big hole there because, this and that. And when you start coding, you actually.
Oh, sure.
One thing I'll add is the specification is, I think, is complete and comprehensive with regard to the protocol. What I'm working on right now is policy, and that's something that we haven't addressed yet. That was going to be in a separate book and is going to introduce a whole other layer of complexity. Unavoidably, but from the point of view of implementation complexity, is worth keeping in mind.
So Scott, Rick, with chair hat on, do you feel that, and I know that's future work and it's difficult to judge, but do you feel that policy documentation is going to have impact on BPSEC as it currently stands?
No, I don't think there's any. I don't think I've not yet seen any need for any sort of impact on the BPSEC protocol specification to make the policy work. I haven't seen anything yet.
There's a section of BPSEC called Security Policy Considerations. It's not normative, but as you're going through this, and we believe it's the minimum set of policy that you need to provide. But if you see any issues there, please let us know.
Right. There was a section like that in the original BSP specification, which I'm sort of using as a checklist to make sure that that's all covered.
So my next question with chair hat on is, I'm looking in the data tracker, and this is marked as in working group last call, and it's been lingering there for a bit. How many people have read this latest draft? I'm looking in the room. Obviously, it's a bit harder to do over Meet Echo, but no. Okay, so ish, I'm seeing. Someone has it printed out in front of them. So as Mark alluded to in our intro slides, TCPCL and BPBIS we're going to push them really hard. I'll probably let BPSEC follow. That doesn't mean BPSEC is not important, and it needs good review. And can I again request people just take a bit of time and try and digest it? It's complicated. Just try and rough out how you'd implement it. Just check all those ifs and else's are where you need them. But that applies to everything, of course. But if you could just spare some cycles on this, I think it would be a mistake to realize we've got a fault in a security document after we've pushed it out of the working group. Otherwise, thank you, Ed.
Yeah, thank you.
With power. I'm thrilled that you
Don't
bring
say
my
too
laptop.
loud.
I had, without this, I've got nothing. Forward back. Okay, good. This is a talk that I gave at a workshop on intelligent space networking in Nanjing a couple weeks ago. And-
Scott, may I in?
Yes.
Sorry. We need a shepherd for the PPSec document. Any volunteer for shepherding the document? Ooh,
What,
we should be pointing someone. Following the process. So you have a report essentially that says, answer all the questions. That's the document being reviewed, your working group last call, implementation. It's an administrative thing, but you follow the document as it goes through.
I will
Oh, thanks.
try. This came out of drafting the latest edition of the bundle encapsulation internet draft. As I was working on it, it occurred to me that there were potentially maybe more depths to what we could do with the IDE than had previously been explored. So I thought I'd try to list some of those and encourage people to think more broadly about what would be implied by this capability. So I will have a short history of bundle encapsulation. I'll talk a little bit about something called aggregate custody signaling and go over the current design of the IBE. And then I'll spend a little time on what I think some of the applications are.
I was wondering if I could make it a slide.
Okay, short history of bundle encapsulation. The original Vibe spec, this is from 2009. Susan Symington, Bob Durst, and Keith Scott at MITRE drafted this and it was conceived as a capability, an application essentially, a bundle protocol application, a capability of the application agent. The motivations listed in the introduction to that document were support for content-centric networking way back then, and the idea there was forwarding of bundles that have been cached. If you've spread bundles through the system and you're caching them because you're being content-centric, how do you take that data and send it to some node that was other than its original destination? So you need a way to do that, and BIBE was seen as that mechanism. A mechanism for specifically targeted custodial retransmission for multicast bundles for reliable multicast, and as a mechanism for security tunneling, and in particular traffic analysis, right? Because it's the only way to send a bundle with the primary block encrypted so that it can't be analyzed by hostile network interceptors. The original BIBE spec never got used very much, as near as I can tell. Maybe somebody's using it and not advertising that fact, but it never got a lot of interest or traction in CCSDS or in IETF really until 2013, where we started looking at security, the same kinds of things that Ed's been talking about that motivated BPSec. A big problem in the original bundle security protocol specification was that there was a conflation between routing and security that was implicit in the concept of having both security sources and security destinations in security blocks that were distinct from the bundle source and the bundle destination. So that conflation could result in bundles being routed to some place without reaching a spot at which they could be decrypted, for example, and is of limited utility. So a way to get around that would be to not allow security destinations other than the final bundle destination. And if you needed to do that, if you needed that capability of an interior source and destination, you could do that by encapsulating the bundle inside another bundle, and the encapsulating bundle's destination would then be essentially the security destination, and you do it in a very clean way that regular routing could handle without any problems. So I wrote a draft in March of 2013 that essentially resurrected BIBE in that simplified form, but as a convergence layer protocol underneath BP. In 2015, 2016, there was a lot of discussion of custody transfer and problems that sort of inevitably come from the original definition of custody transfer in RFC 5050. Two of those were to some degree showstoppers. One was that because not all nodes are required to take custody, when a custodian forwarded a bundle, it really had no, in the general case, had no way of knowing when to expect a custody acceptance signal, because the next node receiving that bundle might or might not take custody, and then it would forward it to some other node who knows who it is, and there's the point at which custody would finally be taken would be completely unknown to the original custodian, to the sender. Worse than that, it is possible, because not all nodes are required to take custody, it's possible for a node that receives a custodial bundle not to take custody, but instead to fragment the bundle. And now there are two fragments going through the system with the custody request signal set. When they reach a node that can take custody, the custody signal goes back, but it goes to nowhere because nobody is taking custody of those fragments. And there's never a custodial acceptance signal coming back to the custodian for the original bundle. So there were these sort of infelicities in the custody transfer system in general, but that didn't remove the fact that in some deployments, you really have to have custodial retransmission in the sense of using the bundle protocol itself as a way of sending acknowledgements back to to whoever is in a position to resend the bundle, because in some cases the return path from a receiving node to the sending node would not be the same as the sending path, and it might in fact be a separate node path that is subject to delay and disruption. Last year, I think we talked about extracting custody transfer from bundle protocol to simplified bundle protocol and to localize all of the complexity of custody transfer in a new document. And in general, the conclusion there that we were working with was that bundle protocol transmission reliability, useful thing, do it between neighboring BP nodes, and that would mean essentially at the convergence layer. So custody transfer at the convergence layer, use bundle protocol as a convergence layer protocol, a reliable convergence layer protocol. And then a moment of clarity, bundle encapsulation was already doing that. So the simplest thing looked like simply building custody transfer into bundle encapsulation and use that BIBE protocol for both purposes, independently or together. That is, use it for cross-domain security, including traffic analysis, and use it for reliable convergence layer transmission over asymmetric paths. Separately from all this, and in parallel to it, back in 2012, there were some guys at University of Colorado in Boulder who were working on the use of DTN on the International Space Station, which had highly asymmetrical links. The downlink was thousands of times higher bandwidth than the uplink. And so for reliable transmission between the space station and the ground, custody transfer, which is what they wanted to use, was not going to work because the number of custody signals required going back up to the spacecraft to acknowledge receipt of data would have completely flooded the very meager uplink bandwidth. Sebastian Kuzminski and Andrew Jenkins developed a mechanism for aggregate custody signaling where the custody signals would go back as bundles just as in RFC 5050, but the custody signals would not be one for one with the acknowledged bundles. There would be an aggregation of custodial acknowledgements into a single bundle. That was originally conceived as an additional administrative record and an additional extension block. It was implemented in ION in 2012, 2013, and it worked actually really well. It was highly successful in operation of the ISS, and the people using it are just big fans. So as we look at migrating custody transfer into bundle-to-bundle encapsulation, a natural adaptation there would be to look at, in fact, putting aggregate custody signaling into bundle-and-bundle encapsulation. Originally, as an option, alongside the original one-for-one custody signaling system in RFC 5050. But as I started looking at it a little bit longer, I could not see any advantage in retaining the old, bundle for bundle custody signaling mechanism. The aggregate signaling did not impose enough overhead to argue against using it all the time. That's what is written into the bundle and bundle custodial transfer draft posted in May. Aggregate custody signaling is supported as an optionally reliable convergence layer mechanism under bundle protocol. The encapsulated bundle may be encrypted, it may be signed, it may be reliably transmitted, or any combination of those. And so that gives us a reliable convergence layer protocol that is based on using bundle protocol as the transfer mechanism, analogous to LTP or TCP. The way this works is that the payload of the encapsulating bundle includes a transmission ID, which is what's used as the mechanism for aggregation, which is set to 0 if there's no request for custody transfer. An expected time of acknowledgement, which the sender computes based on its expectation of the round trip between itself and the topologically adjacent node that it's sending it to, because it's convergence layer, and then the encapsulated bundle. The acknowledgement of the encapsulating bundle is aggregated into an administrative record that comes back in a responding bundle. There are aggregation thresholds in time and size, the same sort of thing that you do with aggregation in LTP. There's a custody transfer disposition code that is in the signal that comes back, and that applies to all of the encapsulating bundles that are covered by the custody signal. And then there are sequences of consecutive transmission IDs, and that's all there is in this return record. If the acknowledgement is not received by the expected time, then transmission of the encapsulated bundle is assumed to have failed, and the encapsulated bundle can be queued for reforwarding. Same as in old style custody transfer. So given this mechanism, there are some things that you can sort of obviously do with it. Here's custodial reliability. Here's an elegant diagram showing how custodial reliability works. There it is. That's bad.
Our wheel.
Oh, there it is. The source bundle is shown in red, the encapsulating bundle is shown in green, and the custody signal coming back is this cross-hatched thing. And so what's shown here is an asymmetric data path where from node 1 to node 2 it goes, it's unidirectional perhaps, and from node 2 back to node 1 the acknowledgement or custody refusal signal comes back by some entirely different path through other nodes altogether. And here's the other original motivation for bundle-in-bundle encapsulation. Here we're showing cross-domain security, and the original source bundle gets encapsulated in an encapsulating BIBE bundle, and the source bundle is signed. That's what the sort of little brick cross-hatching shows. And traffic analysis is basically the same thing, where instead of just being signed, the encapsulated bundle is encrypted, and that encryption is terminated, and the original plaintext source bundle emerges at node 2 and makes its way across the safe part of the network to the destination. But because bundle protocol is being used as the convergence layer protocol, that means that all of the features of bundle protocol can be applied to the convergence layer transmission of the bundle. So for example, suppose you've got a bundle that is in a private network is extremely important, but once it gets into a trunk line, for example, or some sort of a wide area network, in that big pool, it's just much smaller fish, and so while it's expedited in the local networks that produce and consume it, over the trunk line, it's just standard priority, and the encapsulating bundle can have an entirely different quality of service than the original source bundle, a quality of service that's a better match to the network itself. As an elaboration of that, there's this notion of critical forwarding in the extended class of service, and so you can imagine that the original bundle is just sent from the source node to the destination node, but once it reaches the edge of some unstable network, the entry into that network recognizes that the network is a mess, and yet this data has got to get through. So it forwards it with the critical forwarding flag set, which will cause the bundle to travel over not just the one path from node 1 to node 2, but over all possible paths from node 1 to node 2. And so multiple copies of the bundle may arrive at node 2, but the chance of the bundle not making it to node 2 at all are minimized. And from node 2 onward to the destination, it reverts to just being the original source bundle. Another variation on the same thing would be it may be that rather than wanting to send from node 1 to node 2 across this network over multiple paths, it may be that node 2 itself is not necessarily reliable. So rather than focus on sending the bundle over multiple paths to one exit from the unstable part of the network, you might multicast it and multicast it to multiple possible exits from the network to make sure that at least one of them gets a copy and forwards it. And at the end of the unstable part of the path, multiple nodes may have received, each of them received one copy of the encapsulating bundle and forwarded one copy of the source bundle. The destination node may again receive possibly multiple copies of the source bundle, but it's got a good chance of getting at least one of them. Source path routing. This is something that Lloyd Wood pointed out on the mailing list that bundle encapsulation gives us, and I think we can certainly discuss whether or not that's advantageous. But in any case, it does work, and it does provide a way of doing source path routing that doesn't require any additional protocol design. It just comes naturally out of bundle encapsulation. And you can imagine combinations of these things. When the bundle reaches the edge of some unstable, unsafe part of the network, that entry node may determine that it needs to be sent to multiple receivers, but it needs to be signed by node 1 to make sure that those receivers don't drop it. And so it may be that the source bundle is not only multicast, but it's also signed, or it could be multicast and encrypted and then decrypted at each of these points. So in general, what I think we have here with bundle encapsulation is a wide variety of processing options that are rooted in the fact that we're using the bundle protocol as a convergence layer protocol, and so all the features that are provided by bundle protocol are available at the convergence layer, and that I think gives us a lot of options, maybe an increasing number of options as the bundle protocol ecosystem grows and we add more supporting protocols. Bundle encapsulation is being considered for adoption in the working group. It's actually sort of deceptively simple specification. There's really not very much to it. It's fairly straightforward. Implementation should be pretty easy, and it's very powerful, and the applications, I think, are just a matter of imagining what you can do with it. And that's all I have.
Questions from the floor? Questions from Meetico? Don't go away yet. This functionality was in 50/50, and then in BPBIS got removed. So essentially, we're having multiple documents for the same functionality. So it's really within the charter. Do people feel we should adopt this document as a working group document? Yes, no, maybe. Only one?
And both from Utica College, I feel that this should be brought into the working group as a document.
Rick Taylor, without my chair hat on, I think this is important work and should be adopted.
Ed Barena, I think this should be adopted.
Anybody opposed or have any issue? Okay, so let's consider possibly adopted. We'll send an email to the mailing list to confirm.
Great.
And then
Thank you.
we could, then the next step would have for you to reissue the document under draft
Different name.
IETF DTM.
Exactly. Yeah. Good. Thanks.
So next up, I believe, is Ed, who's going to talk about the asynchronous management. Just as Ed comes up, I believe at IETF 101, Ed requested this be accepted as a working group document. I believe it's on the charter. I'm looking for Mark to correct me at this point. I thought the architecture. Okay, right. I'll shut up.
That's the scope.
Yeah.
It's different.
So, sure. Well, so to start with that, when we talk about network management in a DTN, we've broken up the drafts that we've proposed into three areas. The first is an architecture document, which talks about the required processing and the desirable properties and the workflows associated with network management in this space, separate from any kind of data model, separate from any kind of protocol. And that's called the asynchronous management architecture. That was the document that we had requested be adopted. I believe at 100 and 101 from the minutes that was approved, and the others, which were separate, were the data model associated with that and the protocol for exchanging that data model. And I wanted to talk through some of these briefly. So if we start, oh, this is,
That's right. Give me a second. I'm going to see whether this full screen button does what it says it does.
look at that. So there was a hot RFC meeting on Sunday, and we were able to present some of this work there as well. The motivation for why we are trying to do something different for network management in DTNs is to try and address the fact that if we have very remote nodes that are not always part of the network and are not always part of high availability access to operators and managers in the network, then some of the operational constructs that we currently use to manage networks no longer work, particularly pull requests for data, or the idea that performance monitoring happens in a network operations center and network operators can then push things back. We spent some amount of time, some years, going through various approaches to this problem. We looked at mobile code, we looked at expert systems, we looked at things like SNMP and Armon and early NetConf and RESTConf and so on. And what we found was that no one thing answered or addressed the problem that we thought that we had in this scenario. But there were a couple of things that were close, and if we could find a way to put them together usefully, then we would have something that did what we needed it to do. We looked at spacecraft fault management systems in particular. They don't have the security issues associated with mobile code or with flying script or scripting engines. They had stimulus response systems. There were many heritage implementations. They enabled deterministic processing. If something came out from a period of delay or disruption, you were able to forensically account for what happened during the times when you were not actively managing the device, and you knew exactly how it would behave in those disconnected scenarios. The difficulty was on the space side, one, there really was no network CONOP. This was a fault management system. Two, there was very little infrastructure for how to do it. It was very mission specific or space agency specific. So many people do this job in about the same way, but they all do it a little bit differently, and there were no standards. If we looked at network management, we saw lots of standards, but not too many. And we saw some open source tools. We saw large investments, not just dollar investments, but intellectual investments in trying to understand operational workflows. But what we didn't see were the things that made the space systems work very well when you were disconnected, which were what we call mature autonomy models. And when I say efficient implementations, we mean binary implementations and also compressing the protocol stack, because on very embedded devices, and not just spacecraft, but small energy harvesting nodes would be another good example, having 10, 15 layers of stack and processing associated is perhaps not the best way to use your battery time. So the question that we came up with in the AMA was, how do you usefully reason about putting these kinds of things together to manage nodes in an autonomous way and in a networking way? And what would that overlap look like? So we came up with something called the asynchronous management architecture, data model template, and protocol encoding. I have at past IETFs presented some of this before, so I'm not repeating that information here. I just want to go over changes to those documents, but I do urge and recommend people read at least the architecture document, which we think lays out what needs to be done in this area. The AMA is essentially an aspirational document. The ADM is a template document for talking about how to build the autonomy models for individual applications and protocols. And then AMP is the CBOR encoding of those structures so that they can be exchanged efficiently on the wire. In all of that, there's a set of drafts that have been published sort of in and near this working group, and we talk through again that AMA architecture, followed by an application data model, which is the autonomy model. And then just like we have Yang modules, or just like we used to have MIBs, we would have some statement on how we apply instances of those models to various applications to manage them, such as how we would autonomously manage a bundle protocol agent, or how we would autonomously manage a BPSec agent. And then, again, the protocol side, where we have a couple of reference implementations. This is just another view of what those are. Again, AMA, ADM, and AMP are sort of the higher order ones. AMA is the document that we're currently asking and believe we're approved for adoption. ADM was sort of our JSON encodings in the model, and then the CBOR. And here, for those who are interested in going back and reviewing these top three, are those a series of management documents and some other ways of reasoning about it using a database. In general, if we talk about the asynchronous management architecture, we're on version 7 of this. The past several versions, 5, 6, 7, have been very, very small revisions if you look through the differences. Some minor spelling and grammar, some moves of items into a scope subsection, updating the logical data model to make sure that it has all of the items that have come in as we have worked with both the network community and some of the autonomy communities, add a little bit of background on command versus control, and talking about some notional differences between keying off of time and keying off of state in a system. But again, the request here is if you're interested in the topic and you haven't had a chance to read through it, take a look through the AMA specification. The system model is familiar. We didn't see a need to change the basic system model of having agents and managers, and there can be multiple agents and managers, and we talk in the AMA document as to how they can be multiplexed with shared definitions. Again, much like Yang modules and MIBs, we propose something called the application data model, because it just needs more things in it and that operate slightly differently than a Yang module would operate or a MIB would operate. And then if we look at the application data model itself, this talks about I'll go one more ahead, the autonomy model that we believe satisfies the requirements and the desirable properties that we lay out in the management architecture. And that data model has things that we call externally defined data, which are things that are computed outside of the network management system, such as in firmware, A to D conversions, and so on. Literals, which are just that numbers in the system. Operators that can be defined, plus minus sliding average. Controls, which are essentially command opcodes in the system. Tables and reports, which should, again, be familiar from a network management perspective. The ability to define strongly typed variables without tipping into making this a scripting language, which we don't want to do. Macros, which are collections of controls, and then time and state-based rules, which bring together the ability to generate expressions and then call command opcodes together. In all of that, we sort of propose that some of these things are atomic, meaning they really don't change once things are deployed, because changing them would mean updates to firmware, things like externally collected data, the operations that are coded into the agent that they can run, the command opcodes. Obviously, if you add command opcodes in a system, that typically means you've updated the firmware in the system to actually implement new commands. And then there are things that can be dynamic and generate as part of network operators active in the system, adding additional variables, defining macros, defining new reports that can be generated over time, and giving and configuring behavior as to how things should act over based on a function of time or based on state changes in the system. So going back one slide, the ADM template takes that autonomy model, says we believe that that is the smallest necessary autonomy model to do the kind of expressive things that we think need to be done. We probably don't need more, but we probably don't need less. And then we walk through a JSON encoding of that, so that if you wanted to then build out something that says these are the externally defined data and reports and so on for a BP agent or a BPSec agent, we now have a JSON coding for doing that, which is what the ADM document lays out. And the overall operational concept here, again, which is not tremendously different from a workflow perspective than what terrestrial network management does, is to say we have a management model, and this is our autonomy model, and we have a template for representing that in a standard way so that you can build code generators and verifiers and so on, and that individual to applications and protocols, you would populate those templates per. And then that, along with network-specific dynamic configuration, comprises the overall state of management information in your network. So for a few examples to this, and about 8 or 9 of the documents that were proposed were looking at the bundle protocol, BPSec, some of the ion administration utilities, and LTP, and coming back and saying, if we look at what has previously been published on how to manage those things, or in some cases creating that set for the first time, this is what it would look like syntactically expressed in JSON in this template so that we could code generate it and use it for management. So we have a relatively familiar and not very, in our opinion, very verbose expressions for things like externally defined data. There are some bits of syntactic sugar in the system where you can parameterize externally defined data and give you in a sense of associative arrays, which are things that are missing, sometimes ruefully missing from network management systems we have today. We have examples of defining tables, and we have examples of specifying controls. And for example, if we look through the ion administrative utilities, we're able to generate an ADM JSON file for each of those in just a few hours, and then auto-generate the code to do that in ION. And what that sort of rolls up to is, once you have a model and a CONOP and a JSON template and the ability to express these things with certain bits of useful syntax, then generating software to do this management and to run the autonomy engines can actually be reasonably straightforward. So there is one and a second one coming, reference implementation of the AMP, which is the asynchronous management protocol, which is a binary CBOR encoding of how to exchange these models and then how to implement the autonomy on the agent side. And that work is happening. There's some other work to create a Wireshark plugin for AMP that was done to AMP version 03, which was a hand-coded binary, and that's being updated, I imagine, over the next 3 to 6 months to update to the new CBOR encoding. And then there are some Python scripts that we wrote just to show how you could take in these JSON files and then auto-generate, for example, C code that does most of the implementation. Particularly, it could generate function prototypes and the calls for the functions, and someone, if they were inclined, could then go in and just implement the small bits here, which are, if you need to sample a piece of external data, this is how you sample the piece of external data, or if you need to call the function, here is the body of the function that you would call. But really everything else, the autonomy, the generation of the reports and tables, and the calculation of variables, and the time and state-based evaluations you would get for free in these cases. That is where we are in terms of the network management piece. Again, just to come back to this document for a moment, the AMA we claim is a useful way of describing how asynchronous management works and why we need it in a DTN. And then the templates and the protocols we just have as internet drafts to capture the reasoning, the reference implementations, the performance measurements as we go off and do the kind of reference implementations that we need to make sure that we have the specifications correct. That's what I have.
Mark here. As you probably know, we don't have our current charter doesn't doesn't have any real management milestone except collecting requirements. I think my co-chair was trying to find a home or directions from upper layer of the management here, the people, the IETF management, for what to do with this work. And we actually sent an email to the ISG trying to find that answer, hopefully soon, if the direction being we continue here, therefore that would require a charter change or somewhere else, or we're looking for guidance on this. So I guess news later.
Ron Enveld, what was the reaction when this was presented in the hot RFC? Was there any feedback?
Yeah, I mean, I'll let Ed answer if he wants to, but we received positive feedback. I mean, people were interested in it. Whether they were interested in it because it was cool and to do with space, or whether they actually had some interest because it solved some use cases, was harder to judge. And following on from what Mark was saying, I mean, with Ed's assistance, we've been sort of wandering around as many of the ops area and the network management groups to see what overlap there is, what advice and so on they can bring. There is intellectual interest, but people are busy doing what they're doing in ops, which is why we've gone back to the ADs and said, in our opinion, this work has broader reach than just DTN. I personally think, and this is hat off, I personally think DTN is the right anchor working group for the moment. And we should probably look at revising the charter, because I believe the charter says we should look at network management use cases, not go as far as architectures and further on into it. But I think the expertise is currently in this room, so why not keep the work in this room? But I see huge benefit in reaching out to the wider ops area and saying, come and help us do this right, because you have experience, not directly in this use case, but in network management and Yang and all that kind of stuff. Because what I would push strongly back, and Ed knows this, is the little snippets you saw in the presentation there about the EDDs and defining the various atomic items that are available. There are something like 8,500 Yang models out there, which handle the vast majority of terrestrial equipment. And if with my corporate hat on, I'm interested in using this not in a space environment, but actually in a terrestrial environment. And I don't think it's a good time for this working group to spend coming up with parallel specifications to all those 8,500 Yang models. So we need to work out how we can reuse that work in a way that works for us and isn't entirely disruptive. So there's a lot of politics and a lot of communication that needs to happen, but we are trying to do it. But for now, I personally believe we should anchor this in this working group and not try and shove it elsewhere. Because I think the people involved will just have to change seats and go and sit in another working group.
So this is Ed Brain at this microphone. So I would agree with that. Rick and I have gone and talked to a couple of people from ops areas in a few ways. Absolutely, there's a lot of existing work in Yang and NetConf right now. And one of the issues that we have found is that there is a difference between how some of that static data is represented and can be mechanically translated back and forth between representations, and the actual state models and protocols for what you do with it and how you update it. And the difficulty that is happening right now in the ops areas for IETF is that that static representation, which has the bits that are reusable for us, are tightly coupled with the workflows and the protocols which do not work in the DTN scenarios. And what we have found is there are others with different non-DTN use cases that also can't run netcon for a particular reason, or want to run Yang over gRPC or Yang over something else. And we're trying, and there is some general groundswell, but this is breaking new ground. And none of that goes to autonomy, which is simply to say there are static parts of the autonomy model and dynamic parts of the autonomy model. And if we have a data modeling language to use them, that is good. But we still fall back on something that's specifically a DTN type use case, which is, and this is the autonomy model for nodes to follow when they don't have a connection back. So when we look at Anima and some of the other working groups, they start with, here's our flooding message. Here's our synchronization message. Here is our discovery message and the amount of exchange that we go to learn about each other. And that could be fine in some circumstances, but not in others. And so we run into those walls in terms of understanding and agreeing on the problem space. So that's a lot of comments, but generally data model versus ConOps and trying to keep some of it in here while we get other review may be helpful, because I think we in the room understand the problem space.
As a counter argument to keeping it, there's not a counter argument. If we keep it in this working group, we still have to get BPBIS, TCPCL, and probably BPSec slightly behind those two done. So this will not be primary work. This will have to wait for a slight charter update and so on, but at least we know the interest is here. Second point, this is still Rick speaking for those on Meet Echo. I was speaking to some of the ops ADs, following on from Ed's point about Yang being a very tightly coupled with NetConf despite their best efforts. I started to hear conversations about Yang Next and about trying to get a design team or a BOFs together to try and look at where Yang has got to over the last 10 years and say, okay, how do we need to revisit this? So there may be some scope for input from us to say, we like 80% of what you're doing, but this 20% is a no deal for us. So anyway, there's an ongoing conversation. If you are interested in assisting, if you have opinions, take it to the list, come and see Ed or myself and let us know what you think. Thanks.
Any other business before we close the meeting?
Just a quick question. Where are we on,
Your name,
sorry,
please?
Stu Card. Where are we on other convergence layers like the experimental norm convergence layer?
We're happy to receive a specification and documents. I'm not sure it's the right answer you were looking for, but
Scott Burley. Yeah, I know there's a norm convergence layer prototype implementation for DTN2, but nobody's done anything about a specification for it yet.
Rick Taylor here. On a similar note, I'm going to cough again, I'm sorry. I have a prototype convergence layer using HTTP, which is unusual, fairly pointless for the space community, but quite fun to think in terms of mobile phones. What I wanted to reiterate is TCPCL is not the convergence layer from the IETF. It's it's the first convergence layer we're getting through the door. So if people have convergence layer drafts, bring them along. Absolutely.
other comments before my co-chair die? Thank you very much. Enjoy Quebec.
uh,